So today I'm doing number 23 on chapter 10. The question is, two balls with masses big M and small m are connected by a rigid rod of length L and negligible mass as shown in figure below. For an axis perpendicular to the rod, show that the system has the minimum moment of inertia when the axis passes through the center of mass. Show that this moment of inertia is I equals mu L squared, where mu equals small m times big M over the sum of small m plus big M. So first we're just writing down the equation for the moment of inertia, which is the sum of all the r squared times m mass. And then we just plug in the value as on the graph. And then we take a derivative because we're finding the minimum, so we just set it to 0. And our purpose is to solve for x, the distance. And then we get x is equal to small m times L over big M plus small m. And then we can solve for the center of mass. The equation is the m1 times x1 plus m2 times x2 over the mass total. So we can set the left side to 0. So we're plugging m times L plus 0 times big M, and then over the total mass, the big M plus small m. And then we get the same small m times L over big M plus small m. So they are equal to each other. So x equals to the center of mass. So now we're doing part 2. So we can just, now we know that x is the center of mass, so we just plug it back in. So x equal to ml over big M plus small m. So that's just plug it in. And then we're just solving for the second part of the equation. So that the small m times L cancels out. And then we can combine the two parts together. So we're taking out, from the first equation we take out the small m, and then for second equation we take out the big M. So it's m, small m, big M, L squared over big M plus small m, and then big M and small m cancels out with both sides, and then we just simplify it. Then you can write mu times L squared, which mu is big M times small m over the sum of big M plus small m.